Stationary point. Stationary point differentiation, example 3. Determine the nature of the stationary points of y equals 2x cubed minus 3x squared minus 12x plus 5. Right, so we've got a function y equals 2x cubed minus 3x squared minus 12x plus 5. In order to differentiate, we want the function to be in the form of x to the power of n. Therefore, the y, the x, equals n x to the power n minus 1. So these are all in the same form except 5. 5 here is x to the power 0 because x to the power 0, x to the power of 0 equals 1. 1 times 5 is 5. Now, to determine the nature of the stationary point, well, we know what the stationary point is. At the stationary point, that's where the gradient is 0. It can either be a maximum, minimum, or point of inflection. If it's a 0 going straight to another positive, so this is 0 going to positive. So if the 2y, the x squared, is greater than 0, so that's greater than 0, that's 0, then it is a minimum, because you can see here, this will be minimum. Otherwise, if it is less than 0, because that's 0, if this is 0 here, this will be less than 0, so that's less than 0, and that's greater than 0. The 2y, the x squared, will be less than 0, and this will be a maximum. So that's maximum. So that's the kind of nature the question is looking for. Is it a maximum, minimum, or point of inflection? So in order to determine that, we need to find the y dx. The function is now in that format. So now we can differentiate. The y, the x, equals n minus to power n minus 1. So n is 3. 3 times 2, 6. X, 3 minus 1, minus 3 times 2 to power 2 minus 1. That's x to the power of 1. This is to the power of 1. 1 times minus 12 is minus 12. X, 1 minus 1 to power 0 plus 0. Therefore, we've got 6x squared minus 6x minus 12. X to the power of 0 is 1. 1 times minus 12 is minus 12. And that equals 0 at the turning point or at the stationary point. So we've got here now a stationary point. So we need to find the value of x where that happens. Well, we can divide both sides of this equation by 6. So you get x squared minus x minus 2 equal to 0. Now we can simplify this function. This function reminds me of quadratic, which is ax squared plus bx plus c equal to 0. See if we can factorize this. So in this case, a equals 1, so that's 1 here. B equals minus 1, and c equals minus 2. I need to find AC. So if I find AC, A times C, that would be minus 2. 1 times minus 2. I need two numbers I could multiply to get minus 2, the products. And when I add them together, the sum, I get minus 1. 1 minus 2. 1 times minus 2 will be minus 2, and 1 plus minus 2 is minus 1. So that's correct. So that's the sum here. Multiply them by x. 1 times x is x, minus 2 times x is minus 2x, x minus 2x, we get x. So I'm going to replace x here minus x, which is here, with x minus 2x. So x squared plus x minus 2x, x minus 2x is minus x. So we got that back. Minus 2 equal to 0. There's a common factor. There's a common factor here. X is the common factor. So if I take x out, I get x plus 1. Because there's a minus here, and there's a 2 common factor here, so I'll take minus 2 out, and that'll be x. Because I've taken minus out, the sign next to it will change. So this will be plus 1 equal to 0. We can test it to see whether we get the same thing back. X times x is x squared. X times 1 is x. Minus 2 times x is minus 2x. Minus 2 times 1 is minus 2. I can also see another common factor, that and that. And I'm left with x and minus 2. So therefore, my factors are x minus 2, x plus 1 equal to 0. To find the root, I need to set this to 0 and set that to 0. Therefore, x minus 2 equal to 0, x equals 2, x plus 1 equal to 0, x equals minus 1. We need to determine if this is the minimum or maximum, or if this is the minimum or maximum. We could plug in the value for y and find the value of y. When x is 2, we plug that value in there, we can find the value of y. Y will be equal to 2 cubed minus 3, 2 squared minus 12, 2 plus 5. 2 cubed is 8. 8 times 2 is 16, minus 2 squared is 4 times 3 is minus 12, minus 24 plus 5. That equals minus 15. When x equals to 2, y equals minus 15. So that's one point there. And the other point is when x equals minus 1, what is y? So we get y equals 2 into bracket minus 1 cubed minus 3 into bracket minus 1 squared minus 12 into bracket minus 1 plus 5. And that is minus 1 cubed is still minus 1, so that's minus 2. Minus 1 squared is 1, so that's minus 3. That's plus 12. That's minus 12 times minus 1 is plus 12. Plus 5. And that equals 12. When x equals minus 1. So that's the second point. Now we need to find the 2y, the x squared. The 2y, the x squared. So we need to determine which is maximum, which is minimum. If we differentiate twice, so that's the first differentiation. If we differentiate it again, so that would be 2 times 6, that will be 12x to the power 1. 1 times minus 6, that will be minus 6. X to the power 0, x to the power 0 is 1. And that's it, because that will be 0 times 12 is just 0. So that's the 2y, the x squared. When x equals minus 1, the 2y, the x squared will be, well, minus 12 minus 6 is minus 18. So that's negative. That's negative, it's a maximum. When x is minus 1 and y is 12, this is maximum. Let's try when x equals 2. The 2y, the x squared, will be 12 times 2, that's 24, minus 6, and that's 18. So that's positive. So that's greater than 0. That's minimum. So that is minimum. So if we're to sketch this curve, now the curve is cubic, and it cuts this is a positive, A is positive, it's cubic, first quadrant, second quadrant, third and fourth. The curve will start from the third quadrant because it's a positive cubic. A is positive. Maximum point at x equals minus 1. So this is minus 1 here. And y is 12. So that point will be here. So which means the curve has a maximum turning point here. And this is 12. So that's what that meant. And the minimum will be minus x is 2, y is minus 15. So at x is 2, y is minus 15. So there will be minimum here. So that's 2, and this is minus 1. So the curve will come there from the third quadrant, turning point, some other value there, and then goes that way. So this is a sketch here. So when y is 5, so it'll be crossing this point here is 5. That's the y-intercept, 5. Now, these are the turning points here. Stationary point, that's where the y dx equal to 0. And here too, as a stationary point, that's where the y dx equal to 0. You can see the gradient here is positive there, and this is negative. That's what we just got here. The negative is this one here. That value here, that negative here, the gradient is that one here. And this one here is negative here and positive there. So that positive here is, this is the y dx equal to 0. And this is the 2y, the x squared, greater than 0. So that's positive. This one here is the 2y, the x squared, less than 0. So that's negative. And that's this one here. And the one that's positive here is this one. And that's what we did when we differentiate twice.